Introduction to networking. Start this conversation off by talking about why we'd want to learn networking. And I'm sure most of you know that just about everything today is networked. All of our electronic devices, computers, phones, tablets, these are all connected to a network, and without a network, they don't serve much of a function for us anymore even. Other devices like heating and cooling controls for buildings connected to a networked computer can be accessed remotely in some cases. We got an example of a toaster oven here, a smart toaster oven that has a network connection. We'll show you that in a moment. And this whole kind of concept, the Internet of Things. So not just classic computing devices that are connected to a network, but all kinds of devices. In this building we're in, our heating and cooling is controlled remotely. The building manager can log in from home and make adjustments to the internal temperatures of the different rooms, monitor what's going on with the system. In this toaster oven example, all right, if we take a look at the control panel that it has, it's here on the person's smartphone. Since the toaster oven is connected to the network, we can access it from a remote device. So you can control your oven from another room or even from outside of the house if necessary. This particular toaster oven has a camera built inside that will detect the kind of food you have and then select the cooking program for you. But you can actually stream your food cooking on your Instagram if you'd like to share your frozen pizza with the world for some reason. So here's an example of something even like a toaster oven being connected to a network. Most importantly for us here, there's a real employment advantage to knowing networking though. Networking is hard to learn. It's a deep subject, it's a complicated subject. There are a lot of different areas, and when you look up training material for networking or look for help on networking, it's either usually too academic, just covering concepts in a very abstract way, or it's too practical. It's helping you solve one specific problem and not really explaining why it's doing what it's doing. It's sort of hard to strike the right balance for someone learning the subject. And so getting some guidance, especially personalized guidance to get you started, is extremely important. I learned networking on my own, and it was really a slow process, and I made a lot of mistakes along the way because there were gaps in my knowledge that I wasn't even aware of. And so I've come to believe that it's really best for people to learn networking in school. It's going to be the most efficient and the best way to do it. And practically, most people just won't or can't learn it on their own. And since it's an element of just about everything these days, if you know the subject that's hard to learn, you can have an employment advantage over your other peers in your industry. And so there are advantages to knowing this for your employment and just for the way that the world works. So let's get into it. We'll start with the basic concepts. We'll review them. We'll look at some network diagrams, practical example, and then we'll review the concepts again at the end. Coming out of this lecture, the things that you really should need to know are the network connection essentials, IP addresses, subnets, gateway, and the difference between a public and a private IP address. There'll be a few other things that we cover, but if you've got those down, you'll be in good shape and ready for what comes next. So first concept, the IP address. Most networks and the networks we're going to be working on use IPv4, that's version 4. There is also a version 6, IPv6, but the IPv4 version looks a little easier to look at, and it's what most networks use, so that's the one we cover. This IP address is like a phone number or house address. It's the way that you're going to contact a device on the network and a way to know who's contacted you from the network. An IP address is going to look like 4 numbers separated by dots. And each number is going to be a value from 0 to 255. There's 2 examples here. If you've worked on CTP's networking projects before, both of these will probably look familiar to you. Talk about subnets, and this is a complicated subject. Coming out of this lecture, the thing that you should know is that a subnet mask defines how big the network is. What's that range of IP addresses that our network is able to talk to and can use? Basically, a subnet allows us to subdivide a larger network into smaller pieces. We use something called a subnet mask, which looks like an IP address. There's an example at the bottom here. In fact, the most common one that you're going to see is 255, 255, 255.0. Another day, we'll talk about what exactly that means. These subnet masks follow some special rules, and it's a little bit complicated to understand. But for now, just know that this number is defining how big our network will be. We have the concept of a gateway, and the gateway is basically the door to the world outside of your network. When you are on a local area network, your own network, your device can only talk to other devices on that same network. There's actually no way for it to directly communicate with the world outside of your network. And so we have this concept of a gateway. The gateway is what allows our internal devices to talk to devices outside of our network. And that gateway is going to be the inside address of a router, the inside IP address of a router device. A router, as the name implies, routes traffic from one network to another. In this case, the local area network, that's our network that we're on, and the wide area network, which is simply whatever's on the outside of our router, outside of our network. In most cases, this will be the internet, but we call it WAN, is the more general term. Basically, whatever else is out there outside of our network. And the last concept is the public versus private IP address. Our IP addresses in v4 have the range from 4 zeros to 4 255s, huge range of addresses, but some of them have special purposes. We have 3 ranges that are defined called private IP addresses, and they can only be used on our local area networks. They have that special purpose predefined, and we can't use them on the rest of the internet. If an address is not a private IP address, then it's probably a public IP address. Most of the remaining IP addresses are public ones. It's just to remember there are a few other special purpose IP addresses that they're not private and they're not public and they have other specialized purposes, but there's only a few of those. So generally, if you see an IP address, if it's not private, then you can assume that it's a public one. Okay, so private IP addresses, again, I said there's 3 ranges and they're listed in this table below. This first one that starts with 10, this middle one that starts with 172, and then the third one that starts with 192. These are 3 different private IP address ranges that have different number of IP addresses within them. They all work the same, and when you're designing a network, a local area network, you can choose any of them that you'd like to work with. The first one's nice because it's a very large range, and you can easily subdivide it up into multiple ranges depending on how you want to organize your network. The third one's extremely common on smaller networks and home networks. It's often the default network that a home router will use. The middle address range is not used as much, and I believe it's simply because it's just harder to remember. It's got this funny second number in there, which is just makes it a little more complicated to remember, and so I seldom see it used. I've seen one example where it was used where the network engineers set it up so that they'll, if they see an address that starts with 172, they'll know that it's part of this special network that they set up. Other people who are utilizing the network are most likely going to choose an address that starts with a 10 or a 192. That 172 address was their clue to what device they were taking a look at on the network. So it can be used, it works fine, it's just a little harder to remember and it's not that commonly used. This middle column, CIDR, classless interdomain routing, is that slash and then a number at the end of an address. And a lot of modern networking equipment will define a network range this way. That last number is the number of bits that the address can use for the network identifier. And that's kind of a more advanced concept. When we get into subnets, we'll talk about that another day. If you're interested in CIDR, CIDR, you can look this up. There are many resources on the internet that will help you understand it better. So we'll take a look at a couple of network diagrams. This can seem a little bit abstract if you're used to working with the hardware itself, but it's good to learn to make that conceptual leap between a network diagram and the actual practical hardware itself. We'll start with the simplest example. It's two PCs connected by a single wire. You can build a real network this way. It's not connected to a wide area network, the internet, any other device. Just these two computers can transfer files, send messages back and forth. To do this, you'd have to have a crossover cable, which is a special type of network cable. They're not that common these days, so you'd probably have to make one yourself if you wanted to try this out. I show the network configuration for these two PCs. The IP address, and then the net mask. Again, net mask just defines, well, how big can this network be? And the IP address is where that device sort of lives on the network. If the device on the right wants to talk to the one on the left, it would contact 192.168.0.1. And it would let it know, hey, this message is coming from 192.168.0.2. We can take this up a notch to a practical network, and I call this the network building block. This is a great place to start with networking. It's a limited number of devices, it's a simple configuration, but it contains all of the concepts that just about every network you'll ever encounter will use. There are a few other things in networking that aren't represented on this diagram, but if you understand this fundamental network diagram, you can probably understand most of what any network is doing. So I have my two PCs for my previous example, but this time, instead of being directly connected together, they're connected with this device, which is called a switch. Switch has multiple ports, and it allows us to plug multiple devices physically together onto the same physical network. These devices still need to be logically configured so that they know how to talk to each other, but they also need this physical link in order to make it work. This is our router. The picture itself is of a typical home router. In an enterprise situation, it's not going to look quite like this, but we'll talk about that a bit later. This router has two addresses and a wall between them, basically. The inside IP address, 192.168.0.0, you may have noticed is the gateway address for these PCs. And that's because when this PC wants to talk to the outside world, it can't get there directly. It has to go to the gateway address to ask it for help. This private IP address cannot communicate with a public IP address out on the internet. So it needs some help from a router to do that work. If this computer were asking to talk to Google that lives out on the internet, the request would come from this computer through the switch to this gateway address. And then the routing function would cross that barrier to the outside world. Then that request would be sent from this outside IP address, this public IP address, out onto the internet to wherever Google is. Google would respond back, and it would respond back to this public IP address. Google doesn't know anything about this interior private IP address. All it knows is 64.51.3.2 asks for images of cats, and it sent back the page, search result page with cats on it. It hits the outside of this router. This router knows who asked for that page about images of cats, and so it will have that data cross that barrier to the inside of our network, into our network, and then transfer that data to the PC that requested it. All right, so on our local area network, inside of this wall, we all have private IP addresses, and they're all in the same network, so that all three of these devices can talk to each other. Subnet mask defines how big my network is, and the gateway is how this computer can communicate with a device that's not on our network. The router does not make the internet part of our network. Our network lives inside of this wall. All right, let's take a look at this in the practical world. So here I set up two laptop PCs connected to a router, and then that yellow cable from the router in the center connects to the wide area network. Probably the internet, but we just call it the wide area network, whatever's outside of our network. Here's a view of the back of the router. The two blue cables are connected to the two PCs, and the yellow cable is connected to the wide area network. So this is our WAN port on the router, and then this yellow device here is our network switch. It's a 4-port switch, so I could physically plug in 4 devices and they would all be on the same physical network together. It's also a wireless router. We have these antennas, and any device connected by wireless to this router would basically be the same as if we had a network cable plugged into this switch. There's a diagram of that router. My arrow points to the antenna to represent the wireless access point. That access point is actually an internal function of the router, and it will connect the devices connecting wirelessly to this wired network. We have the switch, which is that yellow device. We have the WAN port on a home router. It might be called WAN, it might be called internet. On an enterprise router, the ports are often just numbered. And so you have to look at the internal configuration to know which port is doing which job. And you can often reconfigure them however you'd like. The home router is set up for simplicity. You plug your WAN port into your the connection that your internet service provider provides, your internal devices to your LAN ports, your switch, and it just makes it simple and visually obvious how to set it up. Again, this router is a multifunction device. Routing is just one thing that it does. It's also this access point. It's also a switch. It's also a firewall. It also has a service called NAT, Network Address Translation. Most home routers will also have DHCP, Dynamic Host Configuration Protocol, that will give an IP configuration to any device that you connect to it automatically. Very nice service. And it can also potentially have virtual private networking built into it. Some models do. We'll talk about that another day. All right, so that's our router. If we take a look at that diagram again, we have two networking building blocks now. They're both connected to the internet. And we just duplicated one network in a second place. The only thing that's different is the public IP address. These are two different networks, so they are both connected to the internet. For that to work correctly, they're going to have their own different public IP addresses. Internally, we can recycle these same IP addresses on these two networks, and they'll be the same on millions of other networks, probably. So there's no problem that our inside address for our router, our gateway address, is 192.168.0.0. And same on the right, same on the left. The outside world can't see those addresses. They're private to our local area network. And only our local area network can see them and use them. The outside world only sees this public IP address, and that's why we can duplicate these private IP addresses as much as we'd like on different networks. And that's not to say that you can have two devices on the same network that have the same IP address, though. Since this computer on the left on my right network is 192.168.0.1, I couldn't use that same IP address for this computer on the right. If you did, this computer would complain that the IP address is already in use. And if you ignored the complaint, well, then you'd have two computers with the same address. You have this ambiguous situation, and your network is not going to work correctly. All right, so let's review the concepts. Talked about IP addresses. In IPv4, we have 4 numbers separated by dots. Here are some common examples. And at this point, you should be able to recognize this first one is a public IP address. It's not part of one of those 3 private IP address ranges, and so therefore we can guess that it's public. In this case, this is Google's public DNS server address, 8.8.8.8. You'll see this used a lot because it's so easy to remember, and we often need to have a DNS service configured for various networking purposes. These 2 addresses here, if you worked on CTP's network, will probably be familiar to you. 10.61.0.1 is the gateway address for CTP's network. When my computer I'm sitting in front of wants to talk to the world, it's going to talk to this address, 10.61.0.1. When you're working with a home router, generally by default, the gateway address is going to be 192.168.1.1. That's why when you do a hardware reset on one of those routers, generally you can type this address into your web browser and it's going to connect up to the configuration page for that device. Subnets, again, all you should really know is it's going to define how big our network is. We'll talk another day about how to determine how big our network is based on this number. It's going to look like an IP address, but it follows some special rules. You can't just use whatever you'd like. And difference between public and private. Basic concept here is a public IP address works on the internet. If you have a service on the internet that you want people to be able to address, you need a public IP address. If you want to be able to talk on the internet, well, you need a public IP address, and that's going to be on the outside of your router. That will be assigned to you by your internet service provider. You don't pick it. It's all very well organized, so there's no duplicates in the world. And private IP addresses are going to work on your local area network only. They're not routable on the internet, and they allow us to have these predefined ranges that will work on any local area network. Doesn't matter if they've been duplicated a million times other places. And that's for our internal communication on our local area network. They cannot talk to a public IP address directly. They have to use a router to get to a public IP address. Here again are those ranges, something you need to commit to memory the best you can. And again, if you have a hard time remembering, especially this middle range, just remember the first numbers. Those will be your best clue to have a good guess if it's going to be public or private. You should always verify it. You can look up this information so many places on the internet. Very common information. Finally, that gateway device. That's our door to the outside world. It's going to be the inside address of our router. So whenever we look up our network configuration, one of the elements of that configuration will be gateway. And you'll know that's the address of the inside of the router on the network you're currently on. That router's purpose is to route traffic. Don't forget that box you have at home that you call a router is a multifunction device. It does routing, it does a bunch of other things though. The routing function though is routing traffic from one network to another that normally couldn't talk to each other. All right, so we're going to examine some networks in the next session. We're going to take a look at the commands we can run to look at our own private network configurations, to draw a network diagram for the network we're on, and see how all that works in different operating systems like Linux, Windows, on an Android phone, etc. So I'll see you next time.